Hello, hello. It's me, Ugo, and this is longest substring without repeating characters. So this is a new code thing. I just finished it, so I'm glad I did that. I did buy and sell stock a long time ago, so I haven't touched a sliding window problem in a long time. That's a lie. I have touched a sliding window problem, but I haven't successfully completed it, unfortunately, because that wasn't an OA, and I failed that OA because of that. So, hey, good practice. So, let's look at the problem. So the problem is pretty simple. We're given a string S, and we're asked to find the length of the longest substring that does not have any repeating characters in it. And I guess right here it says try to do this in O of n time. So, I do remember searching up just like simple things about sliding window, because I know it's a topic, but I just didn't know how to do it or what about it. Would ask an AI, and I was like, okay, when do you want to use this for? Like, what scenario, what type of problem? So then I could have like a general idea in case of the OA asking a type of question like that. And one of the questions was, or one of the things that it said was longest repeating something, or longest something like like if there's like a sub length within a larger length. So usually like substring problems will have sliding windows of some sorts, simply because it's convenient and it prevents us from having to loop through the string multiple times. Rather, we could just go through it and pop out the last element and move forward as many times as we need. So with that general understanding, I went into this problem. Um, so yeah, I started off by doing this. So my original approach, oh no, not that. Let me just go over here. Okay. So my original approach and thought process was I'll create a few variables. First, the length, well, a maximum length of 0, and then a left and a right index that will like be the size of the window. So the left and right side of them. And then I'll just create a set called substring, and I'll loop through all the characters in the string. And while the character is in the set or in the substring, I will remove the leftmost character and increment left. So this is to basically move our left over to the like past the first occurrence of a repeated character, since we know that every character before it will not be in the new substrings or any future substrings anymore because of that repeat that happened. So this is a big problem. I wasn't thinking about it too much, but this is actually very slow because this actually degrades my original sliding window approach from O of n to possibly O of n squared, because I had to remove every single individual element one at a time because the set is not ordered. So not convenient, but basically after that I would just add the current number or the current character to the set. I would increment right, and then I just check if the current length that we have is greater than the maximum length. Whatever is the biggest one of these two would be the stored in max length, and we just return that. Or I forgot to update that. Oops. So it's just literally that code, and this worked well. I thought this was the best solution. I was like, okay, it's sliding window, good job. But yeah, no, this while loop just ruins everything apparently. I didn't realize that until Anita pointed it out and told us about an O of n solution. So when I saw that, that's when I did this new one, which is better. I think I could probably find it if I just do this. So she gave us like 3 videos. Mine was essentially this one. It was a little different, but it was basically that one. And then hers is this one. Mine isn't that bad, but it isn't perfect. This one's way better. So in this one, basically, what's different is we eliminate that while loop by using a dictionary instead of a set. So what the dictionary allows us to do is we can track the last index that this character occurred in, which is basically what we're doing right here. We still have the max in the left index, but the right one is going to be what gets iterated through rather than the characters individually. This makes it simpler to just do things. So then we just check if the current character we're looking at is in the thing, and if the current character is in the dictionary already, that means that it might be in the window that we're currently in. So if the last index is after the left index, which basically means so basically, since right is going to be the right end point, we know that the new character is going to be the last element. And because of that, any element, if the index is in any element that's greater than left, that means it's within the window. And because of that, we will know that the current character is within the window, and if it's within the window, that means that it's repeated, or repeating now. So to avoid having to pop out each element, rather than doing that, all we can do, we can just simply update the recent index seen and update the left pointer to simply skip over past the first occurrence of this number. So we're going to go to the last index that this character was seen in, and then go past it, and we're going to set left to be that one. And then we're going to update the new position of the last seen index of the current character that we're on. So that will basically move our window instantly rather than having to do the while loop like I was doing before. And we still get to keep this logic over here, which is just the right minus left thing. So pretty cool. Yeah, that's pretty much what it is. It's nothing crazy. It's just where instead of doing a while loop, we're counting the index. We're keeping track of the indexes and the indices in a dictionary, and just seeing if the current character was last seen within the window that we currently are in. And if that's the case, we skip over it, then update the right index, and boom. Just check if it's larger than any length we've seen before. So that solution, way better. 81% beat, 96% beat. So I originally thought that my original solution was O of n. It kind of is. I'm pretty sure if I check this right now, it's gonna say O of n. Yeah. But this one's truly O of n. This one can become O of n squared pretty quickly. So, I mean, even if we look at Python Tutor, it's not that bad. It's 71 steps for this one, but for the same string, it is only 40 steps in the other one, so yeah. Overall, pretty cool problem. I am sad that I almost got it, but just missed out because of the smallest detail. But that's the closest I think I've come to the most efficient solution on my own. So yeah, that's it. Bye-bye.